All right, so 9.5 is they have problem solving in it, but if you were to look in the book, but the only part that they emphasize for you guys is actually solving for specified variables. So that's what we're looking at. So what that means is your goal is to get your variable, a variable by itself, and on the other side of the variable, the other side of the equal sign would be more so of an expression versus a number. In other words, before we solve x equal to 2. So in this case, you'll have other variables sitting on the other side of your equation. So when I look at this, we have d equal to r times c. And remember, all of these letters represent numbers, so we're going to treat them the same way. So in other words, what I mean by that, if I had 2t equal to 10, and I wanted to solve for t, I would divide both sides by 2. So we would take that same thought process and apply it to what we have here. We have d equal to r times t, and we want to solve for t. So we're going to divide both sides by r. R's cancel, and that means t is equal to d over r. And that's all you need. That's it. Okay.
Question. I have a question. How would you know which variable to use to do the division? Would it automatically be the first one?
It's whatever variable is attached to, okay, well, they're going to tell you which variable to solve for.
Okay.
And then from there, whatever's attached to that variable is what you're trying to move away from it.
Okay, I got it.
See
So
what I
if
mean?
they tell you, for instance, if it's a solve for x, I would use the x instead of the r, right?
Well, okay, let's say if it says solve for r.
Okay.
And so I'm looking at drt. If I'm trying to solve for r, then I need to remove the t. So I'm going to divide both sides by t.
Okay.
Because I want the t to cancel out.
I got it. Thank you.
Mm-hmm. All right, so let's look at another one. All right, y equal to mx plus b, and we want to solve for x. So that means our goal is to get x by itself. That means we need to remove the m and the b from the right side of the equation to the left side of the equation. And so remember, just like we've had before, let's say if we had 10 equal to 2x plus 5, the first thing we would move is this 5 by subtracting 5 from both sides. So we'll take on the same thought process and subtract b from both sides. Now, don't forget your thought process on like terms. If they aren't the same variables, you cannot add them or subtract them from each other. So the best you could do on the left side is write y minus b. So yeah, y minus b equal to mx. Once again, your goal is still to get x by itself. So you have m times x on the right. So that means you're going to divide by m. M's cancel. X is equal to y minus b over m. All right, questions? Any questions? I want to solve for L. All right, so we have P equal to 2L plus 2W. All right, so goal is to get L by itself, so we need to remove everything else that's on the right side of the equation. So let's subtract 2W. All right, so now we have P minus 2W equal to 2L. To get the 2 off of L, we divide by 2. L is equal to P minus 2W over 2. Now, something I need to show you about that phrase before we leave the problem, but make sure we are okay with where we got to. So everybody okay with P minus 2W over 2?
Cancel out those twos.
Said, oh, well, before you go there, that's why I said wait on that, because that's I know people want to go there. I want to make sure everybody's caught up with writing. Everybody caught up with P minus 2W over 2. That's a great question, though, and that's exactly where we're going next. All right, great question, great question. All right, so looks like everybody's good. So now, he had a great question. He is asking about canceling out the twos. Now, there's a right way and a wrong way to do this, and I want to make sure that everybody does it the right way, of course. Now, you can leave this answer like this, and I'll show you why. Now, the wrong way of doing this, which a lot of people make this mistake, so if you wanted to do it, don't feel bad, is that they'll look at the P minus 2W over 2 and want to cancel out the twos just like that. And then have the answer of P minus W. So this is incorrect. Cannot cancel it out that way. Trying to stay consistent with my colors. All right, so the correct way of doing this is that if you do want to cancel out or reduce or simplify, whichever way you want, whichever term you want to use, whatever's in your denominator has to go into each term that's in the numerator. So that would actually be P over 2 minus 2W over 2. Now those 2's can cancel, but that still leaves a 2 that's under that P. So this would be another way of expressing that phrase. All right.
Would they still be counted as correct though?
Now this is still right, yes, but I'm gonna tell you why it was okay in this case to leave it that way. But I want to make sure everybody's okay with what I've said, what you can do and what you can't do, what you should do and what you shouldn't do. Once again, like she just asked, this is still fine to leave your answer that way. But I just know that a lot of people see those twos and they want to go start canceling out stuff. So I'm just showing you why you shouldn't just cancel out the 2 and how you can if you decide that you wanted to. All right, so now all right, so this answer is fine only because the 2 could not divide evenly into each term. Now, if that 2 could divide evenly into each term, you are expected to reduce further. So what I mean by that, this is just a random example. It has nothing to do with what we were just doing. So somebody may say, where did 4 come from? Well, it has nothing to do with that problem. I'm just showing you an example. So if I had 4p minus 2w over 2, now this 2 can divide into 4 and it can divide into 2. So this is the time when you are expected to reduce. And that'll be 2p minus w.
Oh, okay, I got it. Because the 2's cancel out on that side of the W, but you put the and 2 goes into 4 twice. Okay.
Mm-hmm. All right. So, like I said, you must simplify because 2's, like you mentioned, the 2's can, the 2, not the 2's, but the 2 can divide into each term evenly. All right. And once again, I don't know, once again, I know I said it in other classes, so I might be saying once again because I've said it 5 times. But don't forget, they're not going to say simplify all the way down. You know, they're going to expect you to know what I just, wrote in the purple. So in my math lab, let's say if you hit solve down and you stop right here, it will probably give you a hint, say it can be reduced further or something like that. Now, if I were to do if you were to do a test, then it probably would mark it wrong. So it'd be one of those things where you probably have to email me and be like, hey, Mr. Tucker, I don't understand why I got this wrong, blah, 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 blah. And so I probably can give you partial for that, but that's why they will actually mark this wrong if you left your answer in that form. All right. Let's do one more. I'm going to solve for if we had V equal to L times W times H. And we want to solve for W. All of that is multiplication. So we can just divide both sides by LH. L's cancel, H's cancel. And whoa, W is equal to V over LH. All right, any questions before we go to 9-6?
No, that one was the easiest one.
Boo, y'all mad y'all had to do word problems.
You man, we happy. They don't get mad.
I'm about to, this note is for me, not for you guys. I'm about to,
Don't do it to us.
yeah. So let's see, I already have these notes written out. I should have anyway. Yep. Did I not? Yep, there it goes. Okay. All right, hold on. is section 4.5. All right. All right, so of course it's not 4.7 for you guys, it is 9.6. So it makes sense to rewrite the notes if I already have them up, already written for you guys. So in the old book, remember we're doing this pilot, but in the other book it's 4.7. So it's 9.6 for you guys solving inequalities. So let me explain what I have here. So you're talking about a linear equation. A linear equation is what we've dealt with up to this point, like 2x plus 5. The main difference between your linear equation versus your linear inequality, which is what we're going to do in this section, is your equal sign. In an equation, you have an equal sign. In an inequality, you have an inequality symbol. All right. So what's going to happen is the result of a linear equation is that you will get one solution. That's what I have there written in red. The result of a linear inequality is you're going to have infinitely many solutions. So in the blue, you see what I mean? In this case, you will have x equal to 1. Once again, that's your only solution. But when you go down here to the blue for your linear inequality, the 2x plus 5 is greater than 7. You will have x is greater than 1. So that means all values greater than 1 would be a solution or, that will make this statement true. So in other words, if I were to plug in, let's say 10 right here for x, 2 times 10 is 20. 20 plus 5 is 25, and that creates a true statement. 25 is greater than 7. So remember, for an inequality, all you need to do is plug in a value that will make that statement true. So anything that you plug in that will make the left side greater than 7 would be, a solution. That's also considered or called a solution set, not just a solution, a solution set. And you want all the values that are greater than 1. 1 is not a solution of that solution set. Because, if you were to put 1 in there, that would say 7 is greater than 7, which would not be true. So, that's the differences, main differences between your inequality versus your equation, what we were doing before. Once again, you will get one solution with an equation. With an inequality, you will get infinitely many solutions.
And I'm sorry, but that's what you said. That's what you said it was when it's a solution set, the inequality.
Yes, the inequality will give you a solution set.
Okay. All right. Let me see. I'm still writing.
Yeah, you're fine.
Okay.
What it gotta be.
All right, I'm good.
So the way we solve our linear inequalities, I'm going to erase this so we can walk through it. It's the same way we solved our equations.
Real quick, I'm sorry.
Oh, okay. So yeah, the way we solve our inequalities is the same way we solve our equations. We have 2x plus 5 is greater than 7. There's one thing we do have to consider. We'll talk about that later, but all we would do is subtract 5 from both sides, which will give us 2x is greater than 2. Then divide by 2. And that'll leave us with x is greater than 1. So the process of solving is going to be the same that you used previously. All Scroll up. All right. So here are our inequality symbols. We have less than with a bar under it will be less than or equal to, greater than, and then the greater than symbol with the bar under it will be greater than or equal to.
When would you use the ones with the bars under it? When you answer a solution that would be inequality all the time. So when you see the equal signs with the lines under it, it would only be an inequality equation. Inequality equation.
Well, you would use it when you want all of the values less than. I think that's where I'm going next. Yeah, here you go.
Okay.
So this explains the difference between the two. So we talk about, let's say if we came down with our solution, x is greater than 2. That represents all of the values greater than 2. That means 2 is not a part of the solution set. Now, if you say all values are greater than or equal to 2, now that means you're including 2 as a part of the solution set. So it's just about, do you want to include that solution, that the value that you're talking about or not? When you say greater than 2, that means you can get as close to 2 as you would like. You can get infinitely close to 2 as possible and still not use 2. So if you want to do 2.1, if you want to do 2.01, you want to do 2.00000000001, you're fine as long as you're not using 2. But like I said, the second one allows you to use 2 as a part of your solution set.
Got it.
So hopefully that helps, what you were asking.
Yeah, that answered my question. Thank you.
Okay, great. All right. Scrolling up. I move. Somebody still need it?
Yes.
Okay, all right, not a problem. I knew he was gonna ring the doorbell. All right, hold on, guys. Let me hold on one second.
Hello, who is it?
Right. Hold on. I should have fussed him up. Joker, I'm in class. All right, hold on. All right, I'm back. I think he was going to want to talk too. All right, here we go. So now we're looking at interval notation. So whenever you're using parentheses, not parentheses, whenever you're using your less than or greater than signs, you're going to use parentheses. Whenever you're using less than or equal to, greater than or equal to, you're going to use bracket. So the difference between the two, we've already alluded to it somewhat, is that, this is what's going to happen. You're going to have three parts to your answer. You're going to have the solution set that you solve for. We're going to do graphing, and then you're going to have interval notation. Each piece is supposed to reflect what's going on in the other piece. So what I mean by that is that going back here, I want to go back, excuse me. We know that when x is greater than 2, we're going to leave out 2. 2 is not a part of the solution set. When x is greater than or equal to, 2 is a part of the solution set. So that's what these reflect. So the parentheses means that I'm not using the 2 as a part of my solution set. You're going to exclude 2. The bracket means that you're going to include 2. So that's why you would use that right there.
I have a question. So would it take the place of, well, since you said we use that, would we still use the equal sign with the line under it inside the bracket and inside the quotations itself, or we would, what? Is that what you're saying?
No, we're going to use the, excuse me.
Don't choke yourself.
Somewhere down, I don't know what's going on in my throat.
Lift your arms up over your head.
Look now, I'm not 3. All right, so
okay.
But yeah, so no, what's gonna happen? We're gonna use these instead of.
Okay, got it. All right.
Yeah. So, and that's what I'm gonna show you in the red down here. We're gonna use these instead of these.
Okay.
Then, like I said, I'll show you that in a second. And then the negative infinity sign or the positive infinity sign, you will always use parentheses, always, because you never can include infinity, because it will always go, you always go to the next number. All right, so if you look in the red, that's how we would use it. If I have x is greater than 2, the way we started, where my pen go? Oh no. There we go. So if I'm looking at x is greater than 2, I'm going from 2 to positive infinity. So because I have the greater than sign, I'm not using 2, because I want all the values that are greater than 2. So that's why you would use parentheses on the 2. Now down here, I have x is greater than or equal to 2. So instead of using parentheses, I would use the bracket. The bracket will let me know that I get to include 2 as a part of my solution set. Then for the parentheses, for the infinity signs, I will always use parentheses.
Okay, now the question. So the brackets or the symbols are interchangeable, so that's why it's like that?
When you say the symbols, which symbols are interchangeable?
The parentheses and the brackets. I see you got a bracket here and then a parentheses there.
Yes, you can use them, but you use them according to the symbols that you have, your inequality symbols. Yeah.
So you would use them and I guess in terms of how you would want to make the statement. Right.
So, and that statement is going to already be established for you when you, let's still slide. There we go. So, all right, come on now, let's slide. There we go. All right, so this is when the statement is made right here. When they give you your original equation, your original inequality, the statement is made there as far as greater than.
Okay.
And then from there, you're going to, you know, do your solving, and all of your symbols and symbolism that you would use is all based on what you were originally given right here.
Got it. Okay. I understand now. Thank you.
All right. Make sure everybody's good. All right. So now, remember I told you it was a third piece. We're talking about graphing. You know, we have the generic number line. That's what I have right here in this black. Oh no, hold up. Right here, just a generic number line. You have 0 in the middle. All your positive values to the right. All your negative values are to the left. Now, in this first one, we have x is greater than 2. So like mentioned, you want to represent all of the values that are greater than 2. So that would be to the right of it. Everything greater than 2 will always be to the right of it. Everything less than 2 will always be to the left of it. If you're looking at the number 5, everything that's greater than number 5 will be to the right of it. Everything that's less than 5 will be to the left of it. That will always be the case. So if you're looking at greater than, you'll always shade to the right of that number. Talking about less than, you'll always shade to the left of that number. So remember we said that if we have the less than symbol, or not less than, greater than symbol, whether it's greater than or less than, you're going to use parentheses. Notice that we did here, just like we did in our interval notation. And we shade it to the right, all the way to the arrow, which represents infinity. Here we have greater than or equal to. So we use the bracket, just like we did up here. And we still shade it to the right. But notice once again, we use parentheses versus bracket, whether it be interval notation or graphing. And that line under the inequality lets us know which one to use. Say again now?
I have a question. If you don't shade all the way to the end of the arrow, would that be considered wrong?
Now if you're talking about on paper, I probably would be assuming that you're going to your arrow. But in my math lab, you wouldn't have a choice. Because what they're going to do in my math lab, they're going to give you A, B, C, or D. And you would just have to pick which one is the right one.
Okay, got it.
All right. So we have a chart that's going to reflect all of your scenarios. Any questions before I go to the chart? So generically, here are all your scenarios. That green statement, A and B, are real numbers that applies to the chart. So the first row, X is greater than A. We already saw how that plays out. We're talking about the number 2. So I'm just saying for any number, A, the way you would write in interval notation, it would be A comma infinity, using parentheses on both. And then you would shade to the right, parentheses over your A. Now, if it's or equal to, only thing that changes is the fact that you're using bracket over A. Still shading to the right, still A comma infinity. Next one, and I'm just talking through it while you guys are writing. You have X is less than A, so now we're going to shade to the left, using parentheses over the A. And then on the next one, oh, and also recognize we went from negative infinity, comma A. You're always going to write your lesser value first, then your greater value. So you come from negative infinity up to A. You read it from left to right. You're going negative infinity, comma A. Before we went A. The third, these right here.
Oh, okay. Can you say it again?
We going from, you always read or write from left to right. So when you let's look at our chart. Notice we come from negative infinity up to A. Okay. So that is reflected in your interval notation as well.
Okay, I got it.
You know what I mean? So before we wrote A to infinity, but that's because that's how it's read, you know. You go from A to infinity to positive infinity. Let's try to see if I could just erase the red part. It won't let me. Try one more time. I can play with stuff without doing all that. Still won't let me. Okay. All right.
I'm not done. 2 more seconds, please.
Oh no, you're fine. You're fine. I wasn't about
Is that the last one? The very last one, is that A greater than? Can you tell me what this is?
Oh.
A greater than X?
Yeah, I'm going to get to that.
I
That's
mean,
enough. That's like I got 4 different ones that go along with that. So I just want to make sure we're okay with those first 4.
No,
Then I'll explain the next 4.
I just wanted to make sure. Oh, okay. I was writing it. I just wanted to make sure I wrote the right letters.
Yeah, it's A less than X less than B.
A less than X. Okay. Oh, less than. Okay. See, that's what.
Mm-hmm.
All right.
All right. So the next 4 are scenarios that involve the 3-part inequality. We'll talk about that when we get there. But like I mentioned to your classmate, those are less than symbols. So what that says is that X. Now remember, your variable is X, and A and B represent numbers. So what it says is that your solution will be greater than A, but less than B. They'll be in between A and B. And that reflects in our shading. We shade in between A and B. And then in our interval notation right here in the middle, it's A comma B because we're going from A to B as far as our solution is concerned. All right. And then from there, the other 3 are just different variations of it. If you have the or equal to sign attached to A, so you have bracket over the A. If it's attached to B, you have the bracket over B. And then if it's under both of them, then you have bracket over both. And then once again, that reflects in your graphs as well as your interval notation. All right, almost finished, really.
I got myself confused.
All right, are we good? All right, so here's one thing that we need to remember when solving inequalities that's going to be different than when we solve. I said, are we good? And then you ain't say nothing.
Because I didn't look my head up.
Got me going out.
Okay,
Got
you
to my
go.
list.
Go ahead. I'm done. I'm sorry.
No, you good. I'll just mess with you because I can. That's it. Everybody good though?
Yes.
Anybody else? All right. So when solving inequalities, there's one thing that we have to consider that's different than equations. Everything else is the same, so there's one thing. So when solving your inequalities, if you have to multiply or divide by a negative number, then you have to flip or change depending on whatever language you would like to use. You have to change the inequality symbol. And I could have wrote that whole thing. I don't know why I didn't. Probably being lazy. All right. So when solving inequalities, if you have to multiply or divide by a negative number, then you have to flip or change the inequality. Right. Anybody still need green? Okay. So if we have negative 3x is greater than 5, just giving you a simple example of when you would have to do that. Negative 3x is greater than 5. To solve for x, you would divide both sides by negative 3. Negative 3's cancel over here. But for your final answer, you have x is less than negative 5 over 3. Before it was greater than, but because you divided by negative 3 to both sides, you have to change your inequality to less than. Oh, yeah. And then also, I didn't mention you have these two parts of your answer. So when you're talking about graphing on a number line, all you would do, first of all, we recognize that we have the less than symbol, so we'll be using parentheses, negative 5 over 3, and we're going to shade to the left because we want all the values that are less than negative 5/3. And then your interval notation will reflect that as well. You come from negative infinity, comma, negative 5/3, and then you use parentheses over both. All right. Any questions before we do a few more? Like I said, outside of remembering to flip your inequality, if flip your inequalities, you multiply, divide by a negative, everything else will be the same. All right, scroll up. All right. So let's look at solving this one. We have 5x minus 6 is greater than 4x plus 2. So the way you will handle it is by making a decision on which term you want to move first. And we, very similar to when you have an equal sign. I'm going to subtract 4x from both sides. 4x cancels on the right. 5x minus 4x is 1x. And again, minus 6 is greater than 2. Then you add 6. 6's cancel. X is greater than 8. And then for your all three pieces. Now, my math lab may ask for all three. They may ask for just 2 of them. But you should know how to do all 3 just in case. And then, like I mentioned to your classmate earlier, your graphing, you don't actually have to do the shading. They're going to give you A, B, C, and D to choose from. So one may shade to the right, one may shade to the left. Both of them use parentheses. Then one may use bracket. Just doing different variations of what you may think the answer is. But this will be the one that you would choose.
So when we are doing the inequality expression, is it always going to be an infinity sign?
Yes, unless you have the 3-part inequality. So let's go back here, do this real quick. So when you look at these last 4, notice we didn't use infinity signs there, but I'll show you that scenario that you'll see that, you wouldn't do that. So you'll know what it looked like when you see it. All right. Be good with that one. All right. So here we have negative 5x minus 3 is less than or equal to 12. So the first thing we'll do is add 3. 3's cancel, leaving us with negative 5x is less than or equal to 15. Divide by negative 5. And then if you look at my answer in the box, notice you have to flip your sign or change the sign because you're divided by negative 5. So that goes from less than to greater than or equal to negative 3. Because we have the or equal to sign, you put the bracket over that negative 3. Shade to the right because it's greater than. And then your interval notation goes from negative 3 to positive infinity. Bracket over negative 3, but then parentheses over your infinity sign because you always have parentheses over your infinity sign. All right. Questions before we look at, let me see, this last one. Yeah, this last one. Everybody good? All right. So the next one, 3-part inequality. So we have negative 3 less than or equal to 2x plus 1, which is less than 7. So here, this is the situation where we would not be using the infinity sign. And you see why in a second. But whenever you have just 3-part inequality, it's called 3 parts because you have 3 parts. You have, this part 1, 2, and 3. And so your goal is to solve for x, but you want to leave x in the middle. If you go back to that chart, those last 4, notice x was in the middle, then we had our numbers on the outside. So you want to leave x in the middle. So if you, let's say if you didn't have this part and you wanted to solve for x, the first thing you would do is subtract 1 from both sides. Well, since it's 3 parts, it's 3-part inequality, you subtract 1 from all 3 parts. One cancels in the middle. And that leaves you with negative 4 is less than or equal to 2x, which is less than 6. Once again, the goal is still to get x by itself. So now we need to move 2. So we'll divide each piece by 2. 2's cancel in the middle. And that leaves us with negative 2 less than or equal to x, which is less than 3.
Can you go back up, Professor, a little bit? Sorry, I had to use the restroom.
Yep. All right.
Thank you.
Mm-hmm.
Okay.
And so, yep, that'll be how you solve it. And remember, whenever you have this, you're shading in between your numbers. So we're shading in between -2 and 3. It'll be a bracket over that -2 because of the or equal to symbol, and parentheses over 3. And then, we'll make sure everybody got it. And then with your interval notation.
You said that the sign doesn't change with this one?
No, we didn't. No, you only change it when you divide by a negative.
Oh, okay, okay,
Yeah.
gotcha.
Now, if we had to divide by a -2, then that's when we would have a situation like that.
Okay.
All right. I believe that was it. All right. Questions. So like I said, you're solving these the same way you solve your linear equations. The only thing you have to be concerned about, like your classmate just mentioned, is making sure you know when and when not you should flip your signs. The only time you're going to flip those signs, though, is when you multiply or divide by a negative value. All right. So questions on anything.
No, I don't have any questions. I think I asked enough.
Yeah, no, just playing. So let's see. So next class, we will be, I will leave it open for us to do review, because looking at what we have set up here, I'm going to check to make sure. So I don't remember. I'm just trying to coordinate this with with the other courses. Remember I told you we're doing a pilot. So, but if this is correct, we are finished with our first block of topics. So that means at some point we should be looking at setting up for a test. And we're going to talk about that in more detail next class. But the way you guys do your test is that you wouldn't take them with me. You actually take them in the tutoring center. And for those who are going to take a test that had accommodation sheets and everything like that, make sure that you remind me before you take the test. Shoot me an email and say, Mr. Tucker, don't forget, I need to take my test and I need you to set my accommodations, so that I can, communicate that with the tutoring center and everything like that. So next class, I'll have all of the details on that. You take it on your own time. So it's not like there's a rush to say, hey, we got to take it, by Tuesday or anything like that. It is, but you don't want to have it just out there. At some point, you have to take them, you know what I mean? So what I'm going to do is I'm going to create a review. Today is Thursday, yes. So by next class, you'll most definitely have a review test, and the actual test will be up there. But if you click on it, it'll be a password. It'll be password protected, so you wouldn't be able to get in there. But you will have a review that will, streamline your studies. Make sure you're prepared for the test. You know what the test looked like. And then what you'll have to do is contact the testing center, tutoring center, and I'll give you all the information to get in contact with Mr. Davis and all that. So questions on anything I've said today before we close out? Mm-hmm. All right, if not, that's great. So I will see you guys on next class. Have more information for you. Also, bring your questions. So you have a whole weekend to generate questions. I will open up the floor for questions first. So we'll be looking to review, everything we talked about up to this point. So yeah, bring your questions. I'm gonna be here to talk about whatever you want to talk about first, and then we'll go from there. So outside of that, you guys have a great weekend. Be safe, and I will see you on Tuesday.
Wait a minute now, Professor. I need to figure out what am I supposed to do about trying to connect it to my lab. Do you have an 800 number I can call them at or something?
So yeah, I was just letting out everybody else, but yeah, let's see first. What's your last name again?
Davis.
Davis. So I just want to make sure I see that you're in here. Yes, Christina Davis. And so are you using the correct email address?
Well, I don't know. At first, it gave me two different emails, so I don't know if I set it up wrong. Like, you know how you put the email in and you're supposed to put the .vccs. I don't think I included that.
All right, well, I see what you did. The email address that you use is
Mhm.
cnd207
Mhm.
at email.vccs.gov. I don't know who you work
Yeah,
for.
I don't know who I work for either. Like, what in the world? And I didn't realize I did that. So what am I supposed to do to change it?
You can see if you can, but if you know if you know your login, then it's really not an issue. Now trying to think if there will be a time when it will be an issue. I mean, at least you know how you can log in. So whatever password you know
Okay.
you normally use, just that's fine. It's just that your email address has .gov instead of .edu.
So tell me this again. CND207 at email.
I'm about to share the screen. All right, so yours
I
is
don't know
right
what
here.
I was doing. Okay. Dot.
Yeah. So
VCCS
if you had a
dot
wrong
gov.
username, it doesn't matter if you had the right password or not. You're still not getting in. So
Right, and it kept telling me that when I kept going in there, it kept telling me my username was taken or it was already used.
Mm-hmm.
All right, so I'm gonna try to go back and log in with that email and the password that I created and see what happens.
And then once you go
Okay.
in there, go to settings. Settings may let you change it.
Okay.
Go into your settings. It may or information, whatever it's called. It may let you change it. So
Okay.
yeah, just let me know what happens.
All right, I will. Because I
All
was
right.
trying to do my homework and I'm like, what is going on? I couldn't figure out what to do. Okay,
Mm-hmm.
thank you.
Not a problem.
All right, bye bye. Have a nice
Bye.
day.
You do the same.
Bye bye.
Questions on the homework?
Mm-hmm.
Would we be able to go over it? Just two problems, 14 and 15?
14 and 15. Can you just give them to me, or I got to look them up?
Yeah, I could give it to you.
Okay.
It's
Hold
11.
on. Let me go to the screen. Let me share the screen. No screen. All right.
So it's 11 over 12m.
All right.
equals.
Lost my pen. Hold on. Where'd my pen go? I
All
keep
right.
losing this pen. All right. Good. All right. So you said 11 over 12.
M.
M. So the M is in the denominator?
It's it just says 11, 12.
Oh, like that.
Yes, I think so.
Okay.
And then equals 1/6 minus 15 over 14.
Mm-hmm.
And then that's the equation.
Okay. So did you have a way that you started it, or?
I was trying to find the LCD.
Okay. So, well, the LCD, well, say, right here, the LCD between these two is 12. Now, the problem with that is that we have this 14 sitting out here.
Right.
So let me see, what's the best way of showing you? I can, well, one way of doing it is breaking down your numbers to prime numbers. This better. And when I look to break them up, this is 2 times 2 times 3. This is 2 times 3, 2 times 7. And this is 2 squared times 3. So when I look to figure out what my LCD is, the different bases that I see, I have to include. So what I mean by that is that 2, 3, and 7 has to be a part of my LCD. When you break it up like this, we're comparing this, this, and this. The different, break them down to prime numbers.
Okay.
And so 2, 3, and 7 have to be used as a part of my LCD. Now, if I have a power, then I have to use the highest power. So that means 2 squared. All right. So does that make sense? Do I need to re-say that, or?
It's a bit confusing. I don't think we did any of the other problems like this, right?
Well, it was one of those things where in LCD they expected you to already know how to do LCD coming in, so we didn't talk about it. Yeah. So what I did here is I broke it down to prime numbers. Prime numbers are numbers that are can't be divided by anything but one in itself. So when I look at 12, you break that up into 2 times 6, but I can still break 6 up into 2 times 3.
Oh, okay.
So that's where I got those numbers from. So that's 2 times 2. Let's stick with red. That's 2 times 2 times 3. And then since 2 is repeated, I wrote that as 2 squared times 3. All right. So now 6, we already said is 2 times 3. And then 14 is 2 times 7. So when you talk about prime numbers, we broke each one of them down into prime numbers. So then from there, as far as your LCD is concerned, each different prime number you see should be a part of your LCD. You know, same thing as if I had 11 back here, then 11 would be a part of my LCD as well. So if I have whatever my prime numbers that came out of each one of those, then that's what I would use. Now, so like I mentioned before, though, if I have one that's repeated, if I have an exponent, then I need to use that as well.
Okay.
The highest one. So now, is that a little better?
Yeah, so then how do we go about the next step with solving this?
Go ahead and multiply them together. So 2 times 2 is 4. 4 times 3 is 12. And then 12 times 7 is going to be 84.
Okay, so then now do I just multiply all the numerators that I have to multiply with the same as the denominator with LCD, right?
Yeah, well, you don't want to, you're right, you'll multiply each numerator by the 84, but you'll leave the denominators the same. All right.
Okay.
So 12 divides into 84, leaves you with 7. 6 divides into 84, leaves you with like 1, 14. And then 14 divides into 84 and leaves you with 4, 6. And now 7 times 11 is 77M. And it's 14. And then 6 times 15 is 30. Oh,
90?
90, yeah. Go ahead and combine your like terms.
A negative. So then is the answer would be m equals negative 76 over 77?
Yep.
Okay.
Yep.
Okay, all right. I think I got it. I think I could do number 15 based off this one.
Okay, cool. And then if not, just bring it back to next class. I'm pretty sure, you know, your other classmates could benefit from the question as well.
All right.
And like I said, I'm gonna open up the floor for questions first.
Okay.
Next class before we do anything. And if we take up the whole class answering questions, I'm fine with that, you know. So.
All right. All right. All right. Thank you, Professor. You enjoy the rest of your week.
Thanks. You do the same.
All right. Thank you.
All right. All right.
Oh, hey, Mr. Tucker.
Yes.
It's just I'm having a little trouble understanding this book a little, and I'm having trouble with the homework as well.
Mm-hmm.
Yeah, I can't even get past the first question because so having trouble understanding it.
Okay. So what we have to do, because I got to go to my next class, set up for my next
Okay,
class. I got one back to back with this one. So
right.
either shoot me an email if you want to do meet up outside of class, or you can bring your questions to class on next class. Because like I said, I'm going to open up the floor for questions. So you can really take this weekend, generate all your questions,
Okay,
and bring it to class next class. So it's up to you which one you want to do. Or if you just, like I said, if you want to just make sure I got you and nobody else, then shoot me that email and we can see what time we can set
okay,
up
I can
with
do
each other.
that.
Okay.
All right. See you next class then.
All right. Not a problem. All right. Have a good one.